Hello guys, welcome back to Surveying Solution, your number one brand in solutions to all surveying problems. Today we are going to consider some problems on geodetic surveying, and it will be computation on the ellipsoid. Yeah, we are going to be dealing with the semi-major axis, the semi-minor axis, the flattening, eccentricity, and the likes of that. So we have a particular problem in front of us today we are going to discuss on, and the problem says these data you see here, they are the parameter of the Everest spheroid, and then the semi-major axis is this, the flattening is this, and we have to compute for the semi-minor axis the eccentricity, the first eccentricity and the second eccentricity. So this is the problem we are going to solve today on geodetic surveying. So first off, before we do anything, we are going to quote the formula we are going to use. Yeah, we are going to quote the formula. So the first thing is the formula for flattening. The formula for flattening, F is equal to A minus B all over A. That's a very important formula we are going to use. And then the second formula we are going to quote rather, is the formula for the first eccentricity, which is E equal to the square root of A squared minus B squared all over A. So these are our formula we are going to use for this particular problem. The first formula we have here is the formula for flattening, which says the semi-major axis rather minus the semi-minor axis divided by the semi-major axis, whereas the formula for the first eccentricity states that we have the square root of the square of the semi-major axis minus the square of the semi-minor axis divided by the semi-major axis. So now, having quoted this formula, we are now going to start right away. From the parameters given to us, we have seen that we have our semi-major axis, which is A, that was stated here. We have our flattening, which is F. So if we are going to apply this particular formula here, we see that we have value for F rather, we have value for A, but we need B. Therefore, we are going to use this formula first. So we are going to make what? B the subject of the formula. I can actually cite the formula for B, like, okay, since we are looking for B, let's just write the formula out. But I just want us to follow through the step. You know, it's a systematic process, and having established the basics like this, it will be very easy for anybody, because what we are trying to achieve is your independence in any form of assessment, or maybe if you are studying personally for anything, so that you can know how some things come by, you know, and you will not have to cram or stuff like that. So now let's get F. You know, these are the formula we are going to use, but since what we are looking for B, which is this, is in this formula for flattening, and we have F, or F is known and A is also known, that means we can actually make B the subject of the formula. So now let's come down. We have F equal to A minus B all over A, and we want to make B the subject of the formula. So the first thing is, we have something like AF equal to A minus B. How did you get to this point? We cross multiplied this multiplied by this and this multiplied by this. So we have AF equal to A minus B. So since we need B, we can automatically have something like minus B equal to what? AF minus A, which means this A here crossing over to this side. These are just basic arithmetic, but we just have to do it. So since we want to get a positive value for B, we multiply through by what? By minus. So by the time we multiply through by the negative sign, we'll find out that all the signs will change. So we now have B equal to A minus what? AF. You see that I could have just quoted from here that B equal to A minus AF, but it might take some persons off balance if you're starting from the basic. Therefore, we have to do what? We have to show you how we will get what? B equal to A minus what? AF. So you now see that this is very simple, or we can easily continue from here. We are looking for B from the question given to us, which is our semi-minor axis, and this is B as a formula. So what the next thing we are going to do? The next thing we are going to do is we are going to substitute the values into this particular formula. So how do we substitute the values? We now come, since we know the value of A, I think we should start on a fresh page, yeah, on a fresh segment. Since we know the value of A, we now say this implies that our B is equal to, what's our A? 6377.301.243 minus AF. Now this AF is just like the product of A and F. So if we want to get the product of A and F here has a numerator of 1. Since F has a numerator of 1, by the time you multiply A by this F, you find out that the numerator for the product of this AF here will be something like 6377,301.243 divided by 300.80169499.3. So this is what we are going to get. Now, one thing about geodetic surveying is that we have been told that since it's an accuracy surveying, we don't approximate values in geodetic surveying. So whatever value you have, that is what you are going to write it to the highest form of decimal that your calculator can display. There is no form of approximation in geodetic surveying. So by the time you want to press anything on your calculator, any form of geodetic surveying, or maybe when you go advanced, when you start doing some things on geodesy, you ensure that what the result your calculator gives to you, that is what you put in on your answer sheet, or that is what you use to continue your calculation. So now, having said that, let's go to our calculator. Now we can take it bit by bit. We can decide to take it once on the calculator, but we still want to take it bit by bit so that some persons, it will be easy for everybody. Let me just put it that way. Now we are going to divide this. So we now have something like 6377,301.243 minus, so we come to our calculator, we say 6377,301.243 divided by 300.80169,499.3. What do we have here? We have 21,201.01498. Therefore, our B will now be the difference between these two. So our B will now be 6377,301.243 minus the answer we already got. So our B is now equal to 635,6100.228 meter. So this is the value of our semi-minor axis. Now, one thing about this is that it's very simple for you to know if your answer is within the limit. This is an ellipse. It might not be a perfect ellipse. This is an ellipse, and we have a diameter here, and let's see, we have another diameter here. So the idea behind A and B, which is our semi-major axis and our semi-minor axis, is that the semi-major axis is half of the longer diameter. So by the time you look at this, this is the elongated part of the sphere, and this is the shortened part, the flattened part of the sphere. So by the time you look at it, you find out that this diameter is longer than this diameter. Therefore, our semi-major axis will be here, and our semi-minor axis will be here. So this is just like a diagrammatic representation of what an ellipse looks like. Now, by the time you look at something like this, you know that automatically the length from the center to the to this part of the circumference is longer than the length from the center here to this part of the circumference, because this part is the elongated side. Therefore, the value for your A will be more than the value for your B. That is what we want to establish. I hope it is very clear. So by the time you look at it, you find out that this is 637, this is 635. That means this actually is the semi-major axis, and this is actually the semi-minor axis. So I hope you got it to that point. Thank you very much. Now let's go to our eccentricity, the first eccentricity. We are not really much into defining terms, so the theoretical part, you can easily get them. We are only trying to explain some tricks on how to get the solutions to some of these problems. Now we are trying to get our first eccentricity. So from the list of formula we've written down, we've been told that our E is equal to the square root of what? A squared minus B squared all over what? All over A. So far we've known what our A is, and we've known what our B is. Now, using this calculator for ease, I used to tell my mates when we were in school, or maybe when I'm studying alone, stuff like that, I used to put the values on a constant, like alphabet on the calculator, like storing it on the calculator. Let me just put it that way. So we are going to get our A on the calculator, we are going to get our B on the calculator. So this will make us to easily recall. This will make us to what? Easily recall the values without typing them. It saves time and it also enhances productivity. So the first thing is that we are going to store the value of A under alphabet A in the calculator. So what's the value of A? The value of A, which is our semi-major axis, is 6377301.243. On one of my previous videos, I just ran through storing a constant. Okay, yeah, when we are doing traverse computation, I ran through storing values on your calculator. Let me just run through it again. Maybe I'll make a video on it sometime. Now we have shift, and then you press this RCL. You choose any alphabet you want to store. So we are going to store it on alphabet A. So we'll press A. It means that this particular value has been stored on A. So by the time you now press alpha A, this value will come up, which is this. It's very simple. Now let's store the semi-minor axis, which is this. So we have 6356100.228, right? Good. So the same process, we have shift, recall, then B, which means when we press alpha B, our semi-minor axis has been stored on the calculator. That's very simple. Just try and go back and you get it again. So now let's continue. So this is still geodetic surveying, and as I told you, ensure not to make any approximation. Make sure that you write out the answers as they were stated or maybe displayed on your calculator. So now let's continue. We have something like this, which means we have the square root of A squared, which is 6377301.243 squared, minus B squared, which is 6356100.228 squared, divided by our A. What is our A? Our A is what? 6377301.243. So the next step is we are now going to recall those values on the calculator. Now you see it will be very easy. Instead of you to be typing 63 whatever, you just press alpha, the alphabet you stored it, and then you start your work. So the first thing is we are going to get the difference of the square of this and find the square root. That's the value we are going to write at once. So what we are going to do is we can easily write it directly on the calculator, but you know our style is what is to break every step down. So we have a squared alpha a squared, which is this, minus alpha b squared again, which is this. We have a value like this, quite a large amount. The next thing is we are going to find the square root of this answer we got, and the square root of this answer is this. We are now going to write it out, which is 519577.7474 divided by what? 6377301.243. So remember that this this denominator is still our what? Is still our a, which means we can still recall it as what? As a. So we can just come up and say answer divided by what? A, alpha a. So we have something like 0.08147298169. This is our first eccentricity. I hope it is very clear. Please just get it once and for all. This is our first eccentricity. Now we want to compute for our what? Our second eccentricity. The steps are still the same, just that the formula we are going to use is just a little bit different from this particular formula, but the steps are still what? Are still the same. Now, how do we get our second eccentricity? The second eccentricity is almost the same thing as the first eccentricity, which is what? Our e prime. So our e prime is equal to the square root of a squared minus b squared all over what? B. That is our second eccentricity, which is e prime. So the steps are still the same, and to reduce or to save time, we are going to quote this answer here and we change the value here. Remember that the numerators are the same, a square minus b square. We have a square minus b square. Therefore, their result will still be this. So we have 519577.7474 divided by our semi-minor axis, which is this, 6356100.228. Hope you get it. What will now be our second eccentricity? Second eccentricity will still be something like this. So we just write out the numerator, which is 519577.7474 divided by, we recall this is b, and we already have it on our system here, on our memory. So we have something like 0.08174473793. This is our second eccentricity. So thank you very much for coming to our channel today. I hope you were able to get something out of what we just did, and then what we did today summarily is what? To determine or to calculate your semi-minor axis, your eccentricity, your first eccentricity and your second eccentricity, and the steps were well detailed, and I believe everyone got a clear understanding of everything we did. So thank you very much for coming around. If you've not subscribed to the channel, please subscribe to the channel and then like this video, drop your comments. If you have any challenge, any question you want us to do, just go to our about section. You see our Facebook page there. You can join our community there, and then you drop your questions, or you can even contact me with my mobile number on the about section of this channel. So thank you very much. I'll see you guys on the next video. Till then, make sure you succeed.